Mount Olive, North Carolina is very much small town North Carolina. Members of the town in 1926 came together to form Mount Olive Pickle Company, and the Pickle Company's had a strong place in the community's history. I've been impressed since day one, primarily with the people. From the lowest paid operator right on up through the executive chairman, they work hard at their job. My name is Kevin Campbell. I am the environmental supervisor for Mount Olive Pickle Company. Our biggest challenge is we use a lot of salt, and so that means we discharge a lot of salt. My original call to NC State was trying to find anyone who may have an idea for beneficial reuse of some of our brine material and wastewater material.
My name is Doug Call. I'm an assistant professor of environmental engineering at NC State. I'm working on a collaborative project funded by the UNC ROI to investigate the potential for salinity gradient energy production in North Carolina. So this is a multi-institution project. Myself at NC State, my collaborator Orlando Cornell at UNC Chapel Hill, Andy Keeler at East Carolina University, Lindsay Dubbs at the Coastal Studies Institute, and Joe DeCarlos at NC State. So when we use the word salinity gradient, what we mean is if you have two solutions and one solution has more salt than the other, then you have a gradient. If you put the two together, they're going to slowly mix, and really it's that mixing process that happens spontaneously that releases energy. And so that's what we focus on, is a technology called reverse electrodialysis that can recover salinity gradient energy.
When Doug Call arrived, I guess it's been a year ago now, I took him around back to show him the wastewater facility and walked him through step by step the processes. He had an idea for some of our brine material and wastewater material.
The ingredients there at the Mount Olive Wastewater Treatment Plant were perfect for testing in the kinds of systems that we were working with. We're going to be looking at three specific functions that RED systems can do. The first is electricity generation. The second is energy storage. And the third component of the project is wastewater treatment. At the heart, you've got a series of membranes. And these membranes are simply just material that only lets certain ions pass through. If we put in a channel and fill it with seawater, on one side, we have a membrane that only lets things that have a positive charge move through, sodium, for example. On the other side of that chamber, we have a membrane that only lets chloride ions pass through, the negative charge things. On the other side of those membranes, you have fresh water. Well, the seawater, all those ions, they want to get into the fresh water, but they can't because there's a selective barrier only letting certain ions through. And during that process, you create a flow of ions in the system. But in order to actually make electricity, we have to convert that to electrons. And so at two terminal ends of this whole system, you have electrodes which convert the flow of ionic current into electrical current. So if you integrate an RED system into a device called a microbial fuel cell, we can simultaneously degrade wastewater and generate electricity.
He put it pretty much in layman's terms that he wanted to make a big battery out of wastewater. Wastewater in general, as a rule, uses a lot of electricity. To have the ability to generate electricity to help offset some of that cost, that would be a huge benefit.
Salinity gradient energy technologies, they're at the cutting edge of renewables. Nowhere else in the US currently has the size of the research team and the focus on this topic like North Carolina does. Why I'm so excited to be here at NC State and in North Carolina is the fact that there's support and funding to keep pursuing these dreams of out-of-the-box technologies that can provide renewable energy and wastewater treatment.
It's a benefit to be in such a close proximity to universities. They are usually involved with cutting-edge ideas that are outside the box, and you can build off of their experiences and possibly learn of a new idea that can help you change your process to be more efficient, to be more cost effective, to be better to the environment, to benefit the community at large.
All of the energy that's available where freshwater rivers dump into the oceans around the world, we could potentially generate anywhere from 1 to 3 terawatts. So that could potentially power almost half of total electricity that's produced today. This is a potentially inexhaustible and continuous resource for electricity generation.